Okay, Neeraj, let's proceed ahead with your technical snap for thermodynamics, and you are going for interview of DRDO, right?
Yes, sir.
Okay, Neeraj, can you tell me something about what do you understand by thermodynamic properties? What is the meaning of that?
Thermodynamics. Okay, so basically, thermodynamic properties are the characteristics of the system. By using the thermodynamic properties, we can define the state of the system in thermodynamics while analyzing the any system.
So when you say thermodynamic state, what do you mean by that?
So, thermodynamic state means at a given state, we know the if we know the pressure, volume, temperature, then it is a one state of the system. If we consider any system for the analysis, if the any one of the properties is changing, let's say a temperature is changes from T1 to T2, then the state of the system is changes from 1 to 2.
What do you understand by thermodynamic equilibrium?
So thermodynamic equilibrium is defined as if there are multiple types of thermodynamics like thermal equilibrium, mechanical equilibrium, chemical equilibrium. If the forces are if the net forces equal to zero, then we can say that it is in mechanical equilibrium. If the chemical affection or a chemical affinity in the matter of thermodynamic, then we call as a chemical equilibrium.
Okay, and
Just like
what type of thermodynamic processes do we have?
there are various types of thermodynamic process like constant pressure process, a constant volume process, yeah, adiabatic processes, a constant thermal process, uh, sorry, a constant temperature process, or one is a general process that is a polytropic process.
Hmm. Acha, do you have a PV diagram?
Yes,
Do you have pen and paper and can you draw a PV diagram? Draw horizontal
yes.
line on PV diagram.
Okay, PV diagram, horizontal line.
Mhm.
Yes, sir.
And draw vertical line also.
The vertical line is intersecting or which is totally different from horizontal line, sir.
No, does not matter. You can draw anywhere.
Okay, okay.
Now tell
Yes.
me, what are these two processes?
So first, which is horizontal line, we can say that this is the constant pressure process, and the line which is vertical, we can say that this is the constant volume process.
Okay, is there any difference between constant volume process and isochoric process?
Isochoric and no, sir, constant volume process, we can say that it is isochoric process. It is just the name of that process.
You mean to
Just
say
like the
every is isochoric process reversible process?
no, sir, sir, reversible and isochoric process, it is a totally different process, no, sir. Reversibles are the ideal ones, and isochoric process, we can say that it is a constant volume process.
Can you name some reversible processes?
So reversible processes are ideal processes. These are not practically happening process, but we can say that
तो आइस ऑटो साइकिल में आपको आइसोकोरिक प्रोसेस दिखती है क्या?
isochoric, a constant volume process. Yes, sir. The reversible expansion and the heat addition process is in a Otto cycle or
ऑटो
heat
साइकिल
rejection
इज अ
process.
रिवर्सिबल साइकिल, राइट?
Yes, sir. Yes.
तो वो जो आइसोकोरिक प्रोसेस है वो तो रिवर्सिबल प्रोसेस हुई.
A constant volume process, we can say that it is a reversible process.
एवरी
But for
कांस्टेंट
the
वॉल्यूम प्रोसेस
for,
इज
no,
रिवर्सिबल.
no, sir. Constant volume, every constant volume process is not a reversible process.
बट व्हाट अबाउट आइसोकोरिक, इज दैट रिवर्सिबल?
Isochoric, yes, sir, is ideal process. Isochoric process, we can say that it is a reversible process for the analysis or ideal process.
अच्छा, अब आपने ये जो रिवर्सिबल प्रोसेस आइसोकोरिक बना रखी है,
हाँ सर.
तो इस प्रोसेस में इरिवर्सिबिलिटी होगा या जीरो होगा?
Is there present any irreversibility in this process?
Yeah, that is my question. The isochoric process which you have drawn, is there any irreversibility in that? Because this is a reversible process.
Sorry, sir, I can't say anything right now.
Do you know what
I
is
thought,
irreversibility, Neeraj?
yes, sir, I know that. Irreversibility is defined as basically a loss of available energy or a gain in unavailable energy, which
वो
is
ठीक है,
given
लेकिन अगर
by.
मैं आपको पीवी डायग्राम के ऊपर कोई प्रोसेस दे दूं तो उसमें इरिवर्सिबिलिटी निकाल दोगे कैसे आप?
So first, we have to convert that PV diagram, the given PV diagram into TS diagram, or plot this given process in the TS diagram. Then from that we can calculate change in entropy. And if we know the T naught, that is atmospheric temperature or dead state temperature, then we can by the Gauss-Tadola theorem, we can say that irreversibility is equal to T naught into change in entropy of that process.
Is this the Gauss-Tadola equation? Can you frame this once again?
So Gauss-Tadola theorem is equal to irreversibility is equal to T naught into change in entropy.
Of what?
For the irreversibility of the process.
Change in entropy of the process. Is that what you're saying?
Change
And
in entropy of the
unavailable
process.
energy क्या होता है फिर? How do you calculate unavailable energy?
Unavailable energy is equal to, sir, we can say that unavailable energy is equal to T naught into delta S, irreversibility.
You mean to say unavailable energy ही irreversibility है? Is that what you're saying?
Yes, sir.
But just now you said gain of unavailable energy is irreversibility.
For the so if we given the one any state or any process from 1 to 2, after that we if we proceed the state or if we proceed the process, then we know that if the process is gaining or losing available energy or gaining unavailable energy, then we can say that for the losses of available energy, we can say that the process is gone under the irreversibility or some
अच्छा
losses
नीरज जी,
has.
ये एंट्रोपी जनरेशन क्या चीज है?
So, and basically by the second law, we can say that ds is greater than or equal to dq by t. So if we equate the equation, there is a term called that entropy generation present in the equation, and entropy generation it is a path function, sir.
And how do you calculate entropy generation?
For the entropy generation, so we can so I
अच्छा, can you
cannot
tell me what is entropy principle?
entropy principle, so which is mean a second law of entropy.
No, entropy principle is something different.
The entropy principle is that for any processes or any real processes, entropy should be change in entropy should be greater than zero.
लेकिन एनी प्रोसेस में चेंज इन एंट्रोपी इज नेगेटिव ऑल्सो. अगर मैं आपको चाय का कप दे दूं, उसमें से हीट बाहर निकल रही है, तो उसकी तो एंट्रोपी कम होगी.
हाँ sir, but for the particular system, entropy can be negative or positive, but the total entropy generation, that is entropy of system plus surrounding, or we can say that it is entropy of universe is always greater than or greater than zero or
सो व्हाट
increasing.
इज एंट्रोपी चेंज ऑफ यूनिवर्स?
What is the entropy change of universe is equal to, sir, it is a change in entropy of system plus surrounding under consideration, and also equal to entropy generation of the universe, total entropy generation.
Okay, Neeraj, let me give you the feedback here for this part. I must say
Yes,
कि
sir.
अभी आपकी तैयारी अच्छी नहीं है थर्मोडायनेमिक्स की. लेट मी टेल यू व्हाई. देखो, ये जो रिवर्सिबल प्रोसेसेस है ना, 5 रिवर्सिबल प्रोसेसेस हैं.
Yes, sir.
आइसोकोरिक, आइसोबैरिक, आइसोथर्मल, रिवर्सिबल एडिबैटिक एंड पॉलीट्रोपिक.
Yes, sir.
अब आइसोकोरिक जो होता है ना, इज दैट प्रोसेस विच इज कांस्टेंट वॉल्यूम प्लस रिवर्सिबल. देयर कैन बी कांस्टेंट वॉल्यूम प्रोसेस विच इज नॉट रिवर्सिबल, लाइक फास्ट प्रोसेस हो जाएगी. जैसे अगर इफ आई क्लोज अ कंटेनर एंड हीट अप द वाटर इन क्लोज्ड कंटेनर, दैट इज अ कांस्टेंट
Yes,
वॉल्यूम हीट
reversible.
एडिशन, बट इट इज नॉट आइसोकोरिक. तो आइसोकोरिक
Yes, sir.
मींस रिवर्सिबल, वेरी वेरी स्लो. सो आपको एक तो बेसिक उसका नॉलेज नहीं था. फिर गैस-टोडाला इक्वेशन गलत बता दिया. टी नॉट इंटू डेल्टा एस जनरेशन होता है इरिवर्सिबिलिटी, टी नॉट इंटू डेल्टा एस नहीं होता. फिर इरिवर्सिबिलिटी जो होता है, दैट इज गेन इन अनअवेलेबल एनर्जी और लॉस इन अवेलेबल एनर्जी. Unavailable energy is calculated as T naught into delta S of the process. Entropy change of the system can be positive, can be negative. But when we add entropy change of system and surrounding, it becomes entropy change of universe, which is always positive. And delta S of universe is called delta S generation. And that is basically always positive. This is called entropy principle. तो बहुत से बेसिक क्वेश्चन के आंसर नहीं कर पाए नीरज. थर्मोडायनेमिक्स का नॉलेज नहीं है आपको. आप एक काम करो, थर्मोडायनेमिक्स का जो मैराथन है उसको 2-3 बार सुनो. उस मैराथन को सुनोगे, बेसिक्स क्लियर होंगे तो नेक्स्ट चल पाएंगे हम. अभी तुम्हें बेसिक क्लियर नहीं है तो वो तुम्हें निकाल देगा यहाँ से बेसिक्स की वजह से। तो एक काम करो, थर्मोडायनेमिक्स, फ्लूइड मैकेनिक्स, स्ट्रेंथ ऑफ मटेरियल, हीट ट्रांसफर, इनके जो मैराथन पड़े हुए हैं ना यूरोपीडिया पे, उनको 3 4 बार सुन लो नीरज, और फिर टेक्निकल
यस यस।
स्नैप जाना स्टार्ट करो हम लोगों के साथ।
ओके ओके सर, ठीक है।
राइट, तो यू हैव 3 4 मेंटर्स ऑफ टेक्निकल, सबके साथ जितने ज्यादा हो सकते हैं स्नैप लगाओ।